Well, I've said it before, and I'll probably say it again. I don't hate a lot of things, but one thing I really hate is the misuse of the word exponential. This is especially true when it's used in media sources and news sources in situations where it honestly doesn't belong. And this current situation we're in 2019, 2020 is a perfect example of why it's really important to understand what does this word exponential actually mean. From a previous video, and I'll link the video up here somewhere. From our previous video, we ended up with these three scenarios, each scenario having its own number of cumulative cases that are, all of them are increasing on a daily basis. So we had the situation number one with contaminated meat. So we have a nice meat colored column here to represent that. Situation two, we had a water contamination, and you can see those numbers are increasing here in this water colored column. And then over here we have this column here with a viral infection that spread from person to person, and you can see that those numbers increase in a very different way than the two columns to the left of them. Let's take a look at what these actually look like on a graph to give us a kind of visual representation of what these numbers actually mean. All right, we have three graphs here. Again, the red one is for meat poisoning, the blue one is for water contamination, and the green one, which you can barely see down here, just creeping along the x-axis, is for the viral infection. The three functions used to model these sequences are shown over here. I'm not going to show you how to derive those, but maybe in the future I will make a video for that and link it here. So these are the functions anyway. I'm going to get rid of this just so that we have more space to examine the situation. So a quick examination shows us that the red graph obviously starts more steeply than the blue and the green. However, as you can see here, the blue curve that represents water contamination cases, that curve is curving upward, or in other words, not only is it increasing, but the rate that it's increasing is also increasing. So this is one situation when people get really excited and start using words like exponential growth. But I'll go back and point out that this blue line, this is not an exponential function, this is a quadratic function. So if you wanted to call this growth something, you could call it quadratic growth. The shape, the blue shape here is called a parabola. So you could call it quadratic growth, right? And because it has that upward curve to it, you would expect that at some point it's going to intersect the red line here because the red line is straight. It's increasing, but it's increasing at a constant rate. So if we zoom out a little bit, a couple of days, we can find that intersection. And we can see it right here. This intersection is between the 15th day and the 16th day. So at that point, you have the water contamination taking over the meat poisoning total cases. Now, if you are thinking about this green curve, you would be in the minority because these two are obviously much more exciting. The numbers are getting big much more quickly. And if you are someone who's concerned with keeping the public safe, it's very tempting to focus on the red curve and the blue curve because you have thousands of people being affected by these two situations. And For that reason, they probably feel quite urgent if you're somebody who's working in public safety or public health. However, if we zoom out a little bit further, this is where exponential growth starts to get quite interesting. So you'll see that once we zoom out a certain amount, the green curve here has finally started to really curve upward, and it's taken over the red linear function that represents meat poisoning. So that happened at, looks like about 33 days or so. So just more than a month it took to overcome that situation. Now with food poisoning, one thing to remember is that however much food was poisoned in the first place, that's a limited amount. So eventually this line will actually stop going upward because the amount of meat that's contaminated will have eventually been eaten or thrown away by all of the people in supermarkets. Okay, let's keep zooming out and see what happens. Eventually we can see that the green curve, which is the viral infection, actually does overtake the blue curve, the water contamination. And if we trace this down to the x-axis, we find that it's actually not that long after the month at which all of this started. Looks like it's about 35 days, 37 days or so. Okay, so I mean, one basic point to take out of this is that, okay, I get it. Exponential growth is more powerful than quadratic growth. Doesn't seem intimidating at first, but as we zoom out, the picture becomes a little bit more clear. It's tempting to stop here, but I think it is important just to zoom out a little bit further so we can really get a point, an understanding of the magnitude of this situation. So now look at this. Only 40 days into the situation, the total amount of viral infections is almost 40,000, and the water contamination is just about 20,000. So already 40 days in, and the viral infection has almost doubled the number of cases of water contamination. We're not done. Let's go one more week and really get a picture of what's happening here. So we zoom out a little bit, and you see I actually had to change the scales on the y-axis because things have been rearranged so quickly. So if you look at 47 days, which is 1 week after 40 days, the blue curve, water contamination, is hanging around here. Looks like it's probably around 35,000 or so, maybe 30,000. Whereas the green curve representing the viral infection is all the way up here, over 200,000. Go a few more days, go to 50 days, and you'll see that now all of a sudden we're already up to 500,000. So a huge increase over a short period of time. Most important thing about exponential growth is not that it's growing fast. It's not that it's curving upward. It's that it's growing as a percentage of itself, right? So at the very beginning, we had very, very small increases in the green curve because a certain percent of a small amount is still a small number. When exponential growth becomes an issue in terms of public health, and when we really, these situations like the viral pandemic that's happening in the world right now, the thing to be concerned about is what happens when you take a certain percentage of a large number. And the answer is a certain percentage of a large number is going to be a large number. And the larger that number gets, that percentage part becomes greater and greater. And this is the really key thing about exponential growth that many people do not understand. And armed with this information, be really careful about when you use the word exponential growth, and make sure to think really critical about when you hear that word exponential growth being used, because it might just be that it's a way to exaggerate growth that is growing very quickly. So don't mix up concepts of linear growth, quadratic growth, cubic growth with exponential growth. So as we're seeing in the world right now, this is why I believe it's really important to understand exponential growth. For those of us who are sharing information with other people, for those of us who are responsible for planning public health measures, for those of us who are responsible for watching news sources and understanding what they mean, and being able to interpret data. This is why exponential growth is important, because over very short timescales, exponential growth can become a very serious issue.